Hello and welcome to G Fun Facts Online, where we dive into the coolest and most mind-bending tech shaping our world. Today, we're talking about something truly revolutionary. Imagine your smartphone instantly creating a unique piece of art based on your surroundings, or your car's navigation system not just giving directions, but having a real-time, intelligent conversation about the route, all without sending massive amounts of data to the cloud. Sounds like sci-fi, right? Well, it's closer than you think, thanks to the powerful duo of generative AI and edge computing. So what's the big deal with this combo? Generative AI, as you might know, is the brainy tech that can create brand new content. Think text, images, music, even code. And edge computing? Picture this. Instead of your devices sending all their information to a distant data center for processing, edge computing brings the processing power right to the device itself, or very close by. It's like having a mini supercomputer in your pocket or in your car. When these two meet, it's magic. Generative AI running directly on our devices means super fast, real-time creativity and intelligence. Think instant answers, personalized experiences, and enhanced privacy because your data stays local. No more lag waiting for a server miles away. This is crucial for things like autonomous vehicles that need to make split-second decisions, or medical devices that monitor patients in real time. But how do we actually squeeze these incredibly complex AI models, especially the giant ones like large language models, onto our relatively small edge devices? It's a bit like fitting a symphony orchestra into a walk-in closet. This is where the clever stuff comes in, the architectural strategies. First up is model optimization. This is all about making the AI models leaner and meaner. Techniques include pruning. Think of it as carefully snipping away the less important parts of the AI model, making it smaller without losing its smarts. Quantization. This is like changing the AI's language from super detailed descriptions to more concise ones, reducing the model's size and speeding up calculations. Imagine going from a 32-word sentence to an 8-word one that still gets the point across. Knowledge distillation. Here, a big experienced teacher AI trains a smaller student AI. The student learns to be almost as good as the teacher, but is much more compact and efficient, perfect for edge devices. And sometimes, engineers completely redesign the AI models from the ground up, creating new architectures specifically for these resource-constrained environments. Next, we need hardware acceleration. Your average smartphone chip is good, but for heavy-duty AI, we often need specialized brains. These are things like edge AI processors and neural processing units, or NPUs. These are chips designed specifically to make AI calculations fly, and they're getting more powerful and power-efficient all the time. Even good old GPUs and CPUs play a role, though power can be a concern for battery-powered gadgets. And keep an eye out for neuromorphic chips. These are super cool, inspired by the human brain, promising amazing efficiency. Then there's the software. You can't just dump an AI model onto a chip. You need sophisticated software frameworks and toolchains like TensorFlow Lite or ONNX to optimize, deploy, and manage these AI models on all sorts of different edge hardware. Think of them as the universal translators and deployment kits for AI. We're also seeing smart distributed and hybrid approaches. For instance, federated learning allows multiple devices to help train a global AI model without ever sharing their raw, private data. Imagine a group of smartphones collaboratively improving a predictive text model, but your personal texts never leave your phone. Split computing is another trick, where parts of the AI model run on the edge device, and other parts might run on a nearby edge server or even in the cloud, balancing the workload perfectly. And of course, data management is key. You need efficient ways to handle all the data being generated and processed at the edge, ensuring everything runs smoothly. Now, it's not all smooth sailing. There are definitely challenges. Edge devices have limited power, memory, and energy. Trying to run a massive model, like a full precision Llama 2 to 7B, which needs tons of memory, on your average smartwatch? Not quite there yet for most devices. Achieving that ultra-low latency for true real-time generation is also tough, and spotty internet connections can be a pain. Making sure these optimized models work across a huge variety of different hardware is another big hurdle. And we can't forget security and privacy. Keeping the devices and the AI models on them safe is absolutely critical. Plus, sometimes when you shrink an AI model, it might lose a tiny bit of its accuracy, so finding that perfect balance is a constant quest. But the exciting news is that this field is evolving at lightning speed. Researchers are constantly cooking up new, lightweight AI models. You might hear terms like MobileNet or TinyML. Superfast 5G and upcoming 6G networks will provide even better connectivity, making distributed AI even more powerful. We're already seeing AI chips that can run generative AI models directly on our devices, and they're being integrated into PCs, smartphones, and more. The bottom line? The fusion of generative AI and edge computing is unlocking a whole new generation of intelligent, super-responsive, and personalized applications. From smarter autonomous driving and more efficient smart cities to revolutionary healthcare, personalized retail experiences, and advanced manufacturing, the possibilities are incredible. As our hardware gets mightier and our AI models get smarter and slimmer, the magic of real-time generative AI at the edge is only going to grow. Thanks for tuning in to G Fun Facts Online. Join us next time as we explore another fascinating corner of the tech world. Stay curious.